Next, we'll describe the pruning procedure, which takes this cost function that we described and uses it to throw away decisions in the tree that were not that important. The idea is pretty simple. Consider a split in the decision tree. And usually we start from the bottom, so we'll start here with this candidate split to prune. Should we split on term after we split first on credit and then on income? Should we do that split or not? Well, we can use our cost function to figure out what to do. So let's say that the tree that showed everything here has an error of 0.25 on the training data, but we're trying to decide whether to do the split or not. Well, let's see how many leaves we have. We have 1, 2, 3, 4, 5, 6 leaves. And if we use a lambda of 0.3, then the total here, the error plus lambda times the number of leaves, will be 0.25 plus 0.18, which is 0.43. So that's the total, the grand total here. Now, let's see what happens after we do the pruning, if we were to do the pruning. So, if we were to do the pruning, let's say that the smaller tree that's being pruned, where the last decision is being pruned, has slightly higher training error. So the training error goes up to 0.26. You're like, should I really do it? Well, let's look at the number of leaves. It's 1, 2, 3, 4, 5 leaves. And so we're here 5 leaves. And say, okay, we have 5 leaves instead of 6, so 1 less leaf. The training error went up a little bit, but if you do 5 times 0.3, which is lambda, you get 0.15. You add that to 0.26, you get a grand total of 0.41. And magically say, this new tree, T smaller, is looking promising. You know, it has worse training error by a little bit, but lower overall cost. And so since it has lower overall cost, we're going to do that pruning. Good idea. So that's a kind of simplification that it looks okay in a simple example. When you have a massive tree of tons of data, it's hard to imagine how these things come through, but it must happen. Otherwise, you're going to have tremendous amounts of overfitting in decision trees. We're not just going to do it, the pruning procedure for the very bottom of the tree. We're going to keep going up the tree and revisit every decision that we've made, that we've introduced to the tree, and say, is it worth pruning this? Is it worth pruning that? So, is it worth pruning income after credit? Is it worth pruning term after credit? Is it worth pruning credit itself and just have the root node? So we're going to check all those up and then find the best tree after this pruning procedure and output that as our solution. For completeness, I've included here the full algorithm for building up a decision tree using pruning. It's a little bit more contrived. I'll leave it as reference for those who actually want to implement it themselves, but it's relatively simple to implement and not that different than what you might have done in the regular case. This kind of idea is fundamental though, and it's used in every decision tree learning approach out there with small caveats and changes in the parameters, but overall, same idea.